Hello, everyone. My name is Krishna Reddy. I'm a professor of civil and environmental engineering at University of Illinois at Chicago. My presentation title is Tiered Quantitative Assessment of Life Cycle Sustainability and Resiliency. In short, it's known as a TQUALICSR, a framework for design of engineering projects. So before I get started, I want to thank my co-authors, Jacqueline Robles, Suzanne Carniero, Jyoti Chetri. These are all graduate students at UIC for their help in creating this framework and helping me on this presentation. So in my presentation, I want to just give you a brief overview to the sustainability and assessment frameworks. Then I'm going to explain our new framework called TQUALICSR. And then I'm going to show you a case study, where we applied this new framework, and then closing comments. So in US, a lot of infrastructure that has been built, did not consider ecological footprint. As a result, caused a lot of ecological environmental damage, depleted natural resources, increased waste generation, increased pollution, increased greenhouse gases and climate change, ignored resilience, ignored life cycle sustainability. So we can conclude that infrastructure that was built in the past is not sustainable and resilient. So in the future, we should be looking into designing our infrastructure to be sustainable and resilient. Buildings are being designed and built to make them green, and LEED rating system is often followed for this. And the EnvisionTM Rating System is used to develop sustainable infrastructure. And if you look at entire project, the building or other civil infrastructure projects, the rating tools such as LEED and Envision are applied. But these projects will involve a lot of different project components. For example, buildings could have foundation design. Regional stormwater management could include polluted stormwater treatment. Regional transport system could include, roadway pavement design. Polluted site remediation could include decontamination technology selection. So I'm calling these as a project components. And we need to be looking at sustainability as a project component that will contribute towards the sustainability of overall project. While LEED and Envision are applied at entire project, and maybe project is not being applied to LEED certification or Envision certification, but we want to have options for designers to look at sustainability at a project component level. So if you have different project components in a project, and we want project engineers to incorporate sustainability in their day-to-day activities in their design projects. So the question is, how do you promote project component level sustainability so that these engineers or designers can consider the sustainability aspect irrespective of whether they are going for any certifications of their overall projects or not. So for considering the project component level sustainability, one should be aware of sustainability indicators and their metrics, and also life cycle thinking. Sustainability indicators and metrics are based on the triple bottom line: environmental, economic, and social. You need to identify smart indicators. Examples are shown under environmental, like greenhouse gas emissions, air pollutants, such as those. And then you need to have economic indicators, and you need to have social indicators. But these indicators should be such that they can be expressed, in quantitative terms called metrics, and we should have tools to calculate them. And also, these designers and engineers should be aware of this life cycle concept. We need to think about raw material acquisition to material manufacturing to the construction and maintenance, and at the end of the life, demolition, and what should be done with the materials, either recycling or disposal. So, and these triple bottom line aspects, environmental, economic, and social aspects, should be considered at every life cycle stage, and all of them needs to be accounted towards the overall project sustainability. At the project component level, the sustainability assessment tools are limited, and we try to develop a generalized framework. We called it QUALICS. In this one, we look at the environmental indicators, economic indicators, and social indicators, and we apply weighing factors. So we look at the criteria and requirement, and then calculate sustainability index based on the multi-criteria addition analysis, and then weighing factors based on the analytical hierarchy process. We published a paper on this one, and more details are in this publication. And we have applied this framework successfully for different projects. Again, to look at a project component level sustainability. This is an example of contaminated site remediation. We have several options for remediation. We quantified sustainability metrics for each of these options. And we used CIMA Pro for environmental indicators, and we looked at direct costs and social cost of carbon for economic indicators. And we used the social sustainability evaluation metrics, and we did an online survey to look at the social sustainability aspects. And then following the framework, we calculate the sustainability index, and based on the sustainability index, we came up with like M&A, monitor natural accumulations, to be the most sustainable option. But based on the project-specific considerations, giving the social sustainability higher priority, modified capping was considered a more sustainable option. There is a publication on this one. More details are given in that. So recently, we embarked on developing a new framework called TQUALICSR. This framework incorporates the resiliency with sustainability, and it can be applied to entire life cycle of a project or any life cycle stage of a project of any size. And the framework is flexible, tier-based selection of tools based on the information that is available. And in addition to the triple bottom line, we are looking at resiliency indicators so that we have a comprehensive sustainability and resiliency integrated framework. So our framework is shown here. I'm going to go into details of this one very quickly. We have a publication also on this one if you want to get more details on this. Resiliency is important to consider as we are witnessing a lot of these extreme weather impacts, climate change impacts, and these are expected to continue into the future until we make substantial climate mitigation efforts. And again, showing the new framework that we developed here, it consists of 4 different phases. And I'm going to go over very briefly each phase. This is the phase 1. In the phase 1, you define the project goal and scope, define the preferences for the project and what are the technical options, and you look at what are the resilient design options. So that's the linear process, but at each stage, you need to look at the different aspects. In the very beginning, you need to define the stakeholders, engage the stakeholders, and look at their preferences, keeping that in mind. And in terms of the technical options, you need to do the vulnerability and risk assessment. And in doing the vulnerability risk assessment, you need to look at these technical indicators, economic indicators, social indicators, and environmental indicators. And those indicators can be quantified using different tools. And then you can use the multi-criteria addition analysis to calculate the resiliency index. And then again, you feed back that information to the stakeholders and get them involved. And then finally, you identify, what are the resilient design options that you want to pursue. So this phase 1 provides a structured flow to include more than technical considerations early in the design process and helps identify resilient goals, constraints, and indicators in an informed manner. So in phase 1, the most important aspect is resilient design options. And this has to be done based on the vulnerability and risk assessment. And you need to incorporate adaptive measures to make the system resilient. Again, there is a methodology where we do the risk assessment, we incorporate the adaptive measures, and we suggest the monitoring program to keep evaluating the performance of these systems even after they are implemented. And in this one, in the very beginning, we need to identify hazard resilience indicators and metrics. They could be technical, environmental, economic, and social, and they're all interlinked. And based on these interdependent indicators, we can calculate the resiliency index that can help us identify which resilient options is the most preferred option. In phase 2, we get into the sustainability assessment of the resilient options that you came up in the phase 1. In this one, we look at what are the resilience options that you want to pursue in the very beginning, and you want to engage the stakeholders and see their preference. So once you identify potential resilient design options, so you want to look at what are the sustainability variables to represent the problem, and do you need to consider any weightages for those variables, and if you are going to consider different variables, then how are you going to calculate the weighting factors, maybe analytical hierarchy process or other methods that you can use to come up with the weighting factors. And then you define requirements, criteria, and indicators. In the requirements, generally we have environmental, social, and economic. In terms of criteria indicators, we have this triple bottom line, environmental, social, and economic, but also to integrate sustainability and resiliency, we have a resiliency indicators included in this one. So you have requirements, environmental, economic, and social. You have criteria and indicators. As I mentioned, indicators include triple bottom line aspects. In addition to that, we have resiliency indicators in this one. So you apply weighting factors based on analytical hierarchy process that includes the relative importance of different indicators or variables, and you compare the variables against each other, and you derive the weighting factors based on that. And then weighting factors it could be at the tier level also. Tier 3 is more quantitative approach that can be weighed more compared to tier 2 and tier 1 that are based on the limited information. In the phase 3 of the framework, you calculate all the indicator values using different tools. So you have environmental indicators, social indicators, economic indicators, and then you look at what tier that you're using. Do you need to assign a weightage for the tier? And then once you have all the indicators with different values and with different units, you want to normalize those things using some kind of multi-criteria addition analysis method, and you want to do the sensitivity analysis of those indicators. You could have a range of values for some indicators, and you want to also assess the uncertainty. And then using this multi-criteria addition analysis, you can calculate integrated sustainability resiliency index. Before we used to call sustainability index, but since we are integrating resiliency here, so we are calling this one sustainability resiliency index. So here is an example of the requirements: environmental, social, and economic. Most of the criteria and indicators are similar to the sustainability assessment that we have defined before, but integrating this resiliency aspects in the criteria and the indicators is the new aspect in this new framework. And the bottom line is we need to calculate these indicator values using different tools, and so these indicators could be qualitative and quantitative. Some of them are hard to quantify, so we need to have a flexible approach to calculate these things. The bottom line is we need to indicate all these values numerically, and to accommodate amount of information that is available, we proposed a tiered tools approach. Tier 1 is qualitative, and tier 2 is semi-quantitative, and tier 3 is quantitative, more advanced. In the tier 1, we are talking about considering the best management practices. If you are considering the best management practice in your project, you get a score of 1, otherwise 0. So this needs a basic knowledge, and we are able to get some way, to quantify what sustainability aspects are incorporated in the design. So the tier 2 is the rating tools. This is considered a semi-quantitative approach. You come up with the indicators and come up with a numerical scale, maybe 1 to 4. The 4 would be most positive, and 1 would be least positive. And based on this, you can come up with quantitative values for different indicators. So there are some tools such as these reported in the literature, such as social sustainability evaluation matrix. And for this one, you need a little bit more advanced information and your expert knowledge to be able to give a proper rating systems. And third one is the more comprehensive approach, quantitative methods. In this one, you have used the specific data and methods, and you have a software and models that can help you to quantify these indicators. For example, life cycle assessment could be used to calculate the environmental indicators. So this is more detailed, and obviously you need more technical design, detailed technical design, expert knowledge to be able to use this tier. So we propose this tiered assessment because you may not have all the information that you need for every project, for every indicator. So we wanted to have the option to use any information that is available to the user. And also, sometimes you don't have time, you don't have tools or means to perform such assessments. So just as an indicator, I'm just saying here that, if you are looking at economic indicators, tier 1 could be some basic information, tier 2 could be more advanced, tier 3 could be more advanced analysis like life cycle costs or cost benefit analysis. So once you calculate the indicators, we need to normalize those values so that we can integrate them. And generally, we normalize them from 0 to 1. And we use the multi-criteria decision analysis, such as MICE or TOPSIS, and we calculate the sustainability index. Here, we are calling Sustainable Resiliency Index. So similar to the previous framework that we developed. And it's important to do sensitivity and uncertainty analysis because a lot of input values, are needed, and you want to look at, your outcome. Is it sensitive to any of the input parameters? And also, you want to see, some input values could have a different range in the inputs. So you want to look at that uncertainty analysis as well. So, and then at the end, you calculate this Sustainable Resiliency Index based on the multi-criteria decision analysis. So that will integrate both sustainability and resiliency. Once you have those values for different resilient options, now you need to engage the stakeholders and make them aware of all assumptions and your methodology, and select the best option. So the best option may not be the one which has the highest sustainability resiliency index. It all depends upon other factors such as budget constraints, social acceptance, stakeholders' preference, and so forth. So at the end, whatever is agreed upon with the stakeholders, that can be recommended as the best technical design to implement. So this framework can be applied to different projects at different stages of the project and at different scales. It is rational because it considers the life cycle bottom line aspects and integrates those aspects with the resiliency. However, there are challenges to use any framework such as this. It all depends upon the availability and variability of data that you have. There is no standardized tool, and so we have to rely on qualitative and quantitative approaches. Rating systems will depend upon the assumptions, expertise, and biases. So in particular, social impacts are very subjective, and it involves expert knowledge on those things. So just to demonstrate how our framework can be applied, I want to show you a simple case study. This is all about our campus geothermal system. These 3 buildings are being are using the geothermal energy and saving the cost and keeping the temperature constant all around. Geothermal is a substitute for conventional heating and cooling system that uses the electric heating or natural gas or oil. And the idea is to compare geothermal system with the conventional system using this framework. And we use the actual design of the geothermal system, borehole 64 and borehole depth 550 feet. And all the details are given here. And we subjected this one to this framework. Again, the project goal is to assess the sustainability and resiliency of the geothermal system. The stakeholders are university administrators, students, faculty, and staff. and engage the stakeholders through interviews, surveys, and workshops, and performing the vulnerability and risk assessment, and identifying the resiliency indicators, so reflecting the positive and negative impacts of hazard exposure that are technical, environmental, social, and economic. So as an example here, we consider the hazard as the extreme heat, and then we identify the technical, environmental, social, and economic criteria, and these are the indicators, and these are the weightages, and these are the ratings based on the surveys. So following the framework, we can calculate the resiliency index. You can see the resiliency index for both of them are not significantly different. So, this indicates that technical design could be, modified to make the system more resilient. Moving into the phase 2 of sustainability indicators and metrics, we talk about all this triple bottom line aspects: environmental, economic, and social. In addition to the conventional sustainability assessment, we are including the resiliency criteria and resiliency indicators and their values. It could be quantitative or semi-quantitative or BMPs, and they are considered here. And these indicator values are the ones that we have to finally get them. And once we have those things, we can follow the multi-criteria addition analysis and calculate the sustainable resiliency index. As you see here, geothermal system has a high sustainability resiliency index. So even though it has a similar resiliency index, but combining the resiliency with sustainability aspects are much significant in geothermal systems. So overall, you're getting the really high sustainable resiliency index. Again, the decision making is not straightforward. Just look, you just don't look at that sustainability resiliency index and make decisions. So you look at the stakeholders' preference and make the final decision. So in our university, we have the geothermal system that's implemented, and it has been operating quite well for many years. So in closing, it's imperative to consider the sustainability and resiliency in engineering designs. Assessment tools provide the structured methodology to assess the triple bottom line aspects and resiliency aspects. So we created this new framework, TQUALICSR, that integrates the sustainability and resiliency aspects, and it's quite flexible, and it can consider the complex projects or also simple projects at any stages of the project. And of course, the application can be challenging based on the availability of the data, methodology, and assumptions. So even though sustainability and resiliency is not required for regulations or codes as of now, but it's our more responsibility to account those things and do the projects right. So this is my contact information, and if you need more information, you can contact me for this.